All right, folks, now we are going to have some fun, real fun. We're going to apply tolerances to several of the parts. If you read in the textbook at the bottom of page 678, it talks about some tolerancing. That's what we're going to do. However, the tables listed in that verbiage there are for inch systems. So we need the metric systems. Yeah, and there are charts. So um, I'll tell you the way I have worked through this is I took a piece of paper and I wrote down each of the connections listed here, the bushing fit in the pulley, and it gets a locational interference fit. Skip down, 4 or 5 lines, and I wrote the next connection, shaft fit in bushing. And it's a free running fit. Wrote that down, skipped down a few lines. For each of these connections, it requires a fit. So that's going to basically be A, B, C, and D. Okay. And then we can go to the back of the textbook, back around appendix page 40. Almost dropped my book. Appendix page 49. These are the metric tables. The ones preceding this are for a whole basis, and the starting on page 49 are a shaft basis. So we're going to do everything shaft basis because most the things we're dealing with are a shaft that has to be manufactured to a higher tolerance than a cast part. Okay, so I'm going to start with just to show you an example of how we're going to do this. I'm going to start with this one right here, and I've got my drawing started and set up. I want you to make changes to these drawings. It'll make it so much easier for you, and I know it's a hassle to make these changes, but place a dimension, doesn't matter what it is, just place a dimension, select it, right click, and let's go edit dimension style. And this should be on the dimension default millimeter ANSI, okay? And so for units, our precision for a metric drawing should be 0 units. You could certainly leave it at 2 units and turn off display trailing zeros, okay? Under text, let's change these to horizontal. It makes it easier to read, yes. And on the tolerance tab, we want to change our precision to 4 decimal places. Okay. And we're going to leave it at that right there. And then we'll go save and close. Okay, so the thing you see it changes it. Things that had 2 zeros behind it with a decimal drop down to nothing. Okay, so these holes here, let's see, the shaft to frame. The book says it's a sliding fit. So if you look on page A49, across the very top of the chart there, you see the different fits: loose running, free running, close running, sliding, locational clearance. Well, this is supposed to be a sliding fit in a shaft basis chart. And so for what we're doing in Inventor, we don't really care what the basic size is or the numbers, because Inventor is going to do this for us. We just need to know what kind of fit we want. And so we want a sliding fit. And so here I've dimensioned the hole, and you have to change your dimension over to a diameter because it will want to default to radius on this one. And so we select it. go into our Precision and Tolerance tab and pull down to Limit Fits Show Size Limits. Now this is a hole, and so the whole tolerance from the textbook chart is a G7. So we come right here and under hole, we change that to a G7, and then we go OK. And you can see it puts the fit identifier in and then automatically calculates the tolerance for us. Same way over on this hole, it is a G7 also. There we go. All right, so that's how those things are working. Now on the shaft, here's a shaft that goes through there. And you notice that for a sliding fit, the shaft is an H6. And so I applied the dimensions here, and I'll go ahead and show you with this one. Since we're working with the shaft, you come down here and you change it to an H6. Now, if they're opposite, if when you first open up this to edit it, if the shaft is the NA and the hole is, whatever, H7, H2, whatever, just go ahead and change the shaft, change the one that you want, and then it should change the other one to an NA automatically for you. Okay, so let's see, this is the shaft to the bushing. Okay, and so if you look at it, it is it gets a free running fit. So same chart, one column over, and the shaft to bushing of free running fit, the shaft is an H9, which is what I've got right here. And then on my bushing drawing, oh, that's just the bushing. Here's my bushing drawing. Okay, so the inside diameter hole is a D9. Okay, so that's going to be it's a loose fit, so that thing is supposed to spin. The bushing is supposed to spin around the shaft because the shaft is permanently fixed. Now, the pulley wheel, this one, bushing to pulley, is a location interference fit. And so we flip over another page to page 51, and the column in the middle is a locational interference fit. So that tells me we've got a hole P7 and a shaft H6. So I would come in here and the hole is a P7. Oh, I didn't change the dimension style of this drawing. Unfortunately, that sticks with drawings. And I haven't figured out an easy way for you to make changes permanent in your installation. Okay, so that all looks good. I made changes here so it overrides the defaults. Okay, and so that's how, and I'm going to write all this out in Blackboard for you, not everything you need to do because you need to get accustomed to looking at the charts. Now also, we have a couple of other or three more tolerance things at the bottom, and that is the fit between our parts. And it tells you there that we have an allowance of 0.13 and a tolerance of 0.1. And if you remember from your tolerancing kind of stuff in the other 1107 and the print reading class, we're going to go with the frame being our basis of 70, and we will allow we're going to do a tolerance on this with an upper limit of 0.1, and the same on this one. Why won't you double click and edit? And then on our wheel, well, the wheel is probably not, well, it'd be the same kind of circumstance. We take our allowance and we subtract that from the minimum value of the frame. Okay, and that gives us I'm looking at my numbers here. Yeah, that would give us the largest size of the bracket if we take out the allowance, and our allowance is 0.13. So 70 minus 0.13 is 69.87. So this will be 62. Well, I have different values written down on this one because we've got to take into account those washers, and we already have a gap of 0.5 millimeter on either side. So this one, we're not going to deal with the allowance on it for the pulley. We're just going to apply that. We're going to go plus or minus to get a total tolerance of 10. So this would be, we could say, we could give it limits. What do we do deviation? Yeah. Nah, I'll just stick with stacked, just to keep things easy. It would be 62.95 with a lower limit. Oh wait, I got it backwards. Lower limit should be 62.95. $63.05. Okay. Or we could certainly do, come on, dimension. We could do it that way, 63 plus minus 0.05. Either one of those two ways would work. Actually, this probably would work better in the way that those things look. And then I don't have a bracket drawing set up, but there would be a similar thing with the frame to the bracket. And I'll write those informations out for you. So we're going to make some tolerance changes. Oh, one last thing. I almost forgot. Where are we at? Our bushing. It says to shorten the bushing by 0.25 of a millimeter. So go back into your part 7 and edit the sketch to shorten it by 0.25 millimeters. Save that, update your thing here, go to your assembly file, do the update, go to wireframe, and then you can click on the part number right here, and it will highlight it. And if you followed my method of constraining things, I constrained it to this right side, and so that shortened it over here on the left side by 0.25 millimeters. And that is certainly okay for what we're doing. And I know you're thinking, oh my gosh, why did you do all these changes, Mr. Reese, here at the end after we've got everything already fixed up? I said, well, when you go to work somewhere, you're going to do all this work getting a project done. You're going to give it off to your boss to check it, and he's going to mark up your drawings and give it back to you and say, you got to make these changes. And then you're going to make those changes. You're going to give it back to him, and then he's going to give it to his boss, and he's going to check it, and he's going to send it back down, and you're going to make changes, and then it'll go, kind of back and forth like that several times. Don't get discouraged. It's just the process. It's how things work. It rarely will be perfect the first time that you do it and turn it in. Okay, so tolerancing. If you got problems, shoot me an email, come see me, okay?